it can rest at any point. Alright, so first off, I'd like to point out the crankshaft and how this is built. So um, here, right here, there's a 90-degree bend so that the piston over here and the displacer over here are at a 90-degree offset. This helps so that when the displacer is up, the piston is on its way down, going halfway down, and then when the displacer is down, the piston is coming up. So this helps create the cycle of the Stirling engine. So before you can get the Stirling engine to work, you need to use the heat source. So I've already lit the candle, and the air inside is getting warm. Then the engine won't start off on itself, and so you need to give the disc a little kickstart. So once you do that, the engine should start going. So as it's going, the flywheel spins, and the balloon inflates and deflates depending on where the pressure of air is. So now I'm going to bring us into the Stirling engine so we can see what's happening and why it is happening. Okay, so we're going to start at when the displacer is at the top, and in this phase the air beneath is being heated by the candle, and as a result of this heat, the air pressure rises in the engine, and this causes the balloon to fill with air, and it drives the power piston upward. So this next phase should show that the pressure of the heated air is going to make this balloon go up. Here we go. So as the balloon goes up, the displacer obviously goes down, and at this stage the displacer is at the bottom. The balloon is at its halfway point, and the ice cube will cool this air in here, causing the pressure in this vessel to decrease. And so when the pressure decreases, the power piston here will drop, and that will cause the displacer to rise again. So here we go. The power piston is going to drop, and the displacer is going to rise. So as we go through the cycle, you can see that the heating and cooling process continues on, so that the displacer goes up and down. It is important to say that in order for a Stirling engine to work, the container must be sealed almost completely. Of course, there's going to be a little bit of a hole right here, but you really do want a good seal so that air doesn't leak out, and if air were to leak out, the whole pressure would not work. Okay, to illustrate what I was telling you earlier about how the crankshaft must be at a 90-degree angle to or the crankshaft connecting the power piston and the displacer needs to be at a 90-degree angle, this little bend right here. To show you that, I'm going to point you over to this graph which shows the position of the power piston part of the crankshaft and the displacer part of the crankshaft. So notice that as we go around, it's a sinusoidal wave, and um, the phase is offset by 90 degrees. When Robert Stirling invented the Stirling engine in 1816, he came up with a engine that could potentially be a lot more efficient than the internal combustion engines that we use in our cars today. Unlike the internal combustion engines, Stirling engines don't produce any exhaust because all the gas is within the engine, and the heat source is the power supply. Um, so if scientists could come up with a engine that could be used in a car, this could potentially be very beneficial to our planet. Thank you for watching this presentation. I hope it's been informing and that you've learned a little bit about the Stirling engine. Um, Thanks.